When you're dealing with an equation of a circle, there's a specific form that it fits, and the equation of a circle is given as follows. It's x minus h squared plus y minus k squared is equal to r squared. So this is the Cartesian formula for the equation of a circle. And now, this is based on something that you should be familiar with, and that is if I gave you a circle with the center hk, and I said it had some radius r. Okay, so here is the circle that's represented there. Okay, any point that falls on this circle right here has the coordinates xy, some xy that fit for this equation. So it should make sense that if I wanted to find the distance between this point and this center point, then I can use the distance formula to say r, the distance, radius, is equal to the square root of the difference of x's, so x minus h squared, plus the difference of y's, y minus k squared. And then just to solve this, I could get rid of my radical by squaring both sides. And by doing that, you see that you can derive this equation of a circle. It's simply the distance formula. It's just a little more specific because it tells you specifically the h and k value are the coordinates of your center, and your radius is that distance, r. Okay, so using that, you should be able to find several different applications of problems. Okay, I'm going to go through the two easy applications first. The first would be and what if I asked you the following? And so if I gave you the diameter of a circle equals 18, and its center is at the point -1, 5. Find the equation of this circle. So if you were looking to find the equation of a circle and you were told what its diameter and center are, you can solve this relatively easily by performing the following. Okay, first of all, we need to interpret the diameter to find its radius. So if the diameter is 18, what does that mean its radius is? The diameter is twice the radius, so the radius is half the diameter. So you know your radius is 9. Here's your center. So you can use these two pieces of information and plug in directly to h and k and r and get your equation. So our equation for this circle is x minus the x coordinate, -1, quantity squared, plus y minus our y coordinate, 5, quantity squared, and that's equal to our radius 9 squared. What is 9 squared? 81. And so you can solve this type of problem extremely quickly just by plugging all the pieces into the equation of a circle. Okay, there's another type of problem that you might see that again is pretty basic, and that is if I gave you the equation of a circle and I asked you to find the center and radius. Okay, could you do that? Once again, relatively easily. You just have to interpret the equation of a circle, figure out where the pieces or what the pieces mean. Okay, so radius is pretty simple. What's the radius for this circle going to be? The square root of this number, so square root of 36 is 6. And then the center, again, it's easy. There's a couple different ways students tend to interpret the center. A lot of students will just take the opposite of whatever term is inside or being applied to the x and the y. So the opposite of -6 is 6. The opposite of 1 is negative 1. That does work when everything's written in this form. The way that I will always suggest you use, or the way that you'll always hear me say if I'm going through a problem like this, is instead of taking opposites of things, because when you're working mathematically, this won't always be written x minus 6. It might be 6 minus x, right, or 1 plus y, that kind of form. Because of that, I will always in these cases say your x coordinate is whatever value of x would give you a 0 inside here. So what value of x would give you a 0 in this expression? 6. And what value of y would give you a 0? So that's how I come up with them. It's the same thing, although if you just take the opposites, it's not always going to apply. There might be a few cases where it doesn't apply well. Any questions on these? These are the easy types of problems dealing with equation of a circle. What I would like to do is take the problem that we solved right here, and I'd like you guys to look at how the steps are laid out in a formal proof. So step 1 is always going to be given. Step 2, where do we get that equation? Good. So this is the diameter formula, or the equation for diameter. And then what did we do with that equation? We substituted in the value for the diameter. Plug that in, and then to solve it, what did we do? Now, did we divide both sides by the same thing? Yeah, so we'll call it division property. And now where did we come up with the equation in step 5? Equation of a circle. And once we did that, what did we do to change to step 6? Substituted in the values for h, k, and r. And then here's, again, this is kind of the case of what I had mentioned yesterday and the new justification. So what mathematical operation occurred right here? This is subtraction, right? If you put addition, that's fine, because subtracting is equivalent to adding the opposite. But it's a subtraction here. And then what happened on this right side? You multiplied, or you took something to the power or squared it. So you have two different operations going on. They're not being done to the both sides of the equation equally. So the way that you could justify that is the all-encompassing term simplify. Anytime you do multiple mathematical operations and it's restricted to just one side of the equation, you can call it simplify and you're fine. Now, if it had subtracted from both sides but not the same amount, just combined like terms using subtraction, you could put just that operation, subtraction, and be fine. And we'll see that here in just a moment.